Sathyabama Institute of Science and Technology.
Hello everyone, I am Parveen, Assistant Professor, Department of CSE, Sathyabama Institute of Science and Technology. Welcome to the presentation on datasets for machine learning. Have you ever wondered why dataset is the lifeblood of machine learning? This presentation will explore all the fundamental concepts that is related to how datasets are going to play a very major role for machine learning projects. First of all, let's go to the introduction. A dataset is a structured collection of data that is organized and formatted in a way that makes it suitable for analysis, interpretation, and processing by computers. So, first of all, let me have a problem. I have a problem for machine learning and I'm going to propose a solution for the same. First of all, I will construct my dataset and I will transform the data and I will train the model and use that model to make predictions so that these predictions can be either a success or a failure. Why data sets matter? They make it easier to conduct the analysis and perform mathematical operations. They also help to make sense of an overwhelming amount of numbers and information. Data analysts perform a variety of techniques on data sets to extract valuable insights. We have different types of data sets. First of all, we have tabular data, text data, image data, time series data, and spatial data. This is an example of a tabular data where I am having rows which is giving me the observations and columns are giving me the attributes for those observations. Here, this is actually used for classification as well as for regression. Next, we go for the text data. This text data is actually using textual information and it can be used for natural language processing and it will be doing tasks like sentiment analysis as well as text classification. Next, we go for image data. We can see a huge number of cars in this data. This data consists of the images for different types of cars and this is actually used for image detection as well as object detection. Next, we have time series data. It consists of different time series. Here, we have the different temperatures are given on the y-axis and the timings for the different for that particular day is given in the x-axis. This is actually used for weather condition predictions and weather forecasting. It's also used for trend analysis. Next, we go for spatial data. This is an example of a spatial data where I am trying to find or locate a bag. This is an example of a room where I am having a living room or library, reading, bookshelf, door, exit, relaxing chair, table, TV. I am trying to locate this bag in all of these particular places. What are the characteristics of good data sets? The size plays a very important role in a good data set. As far as the size is concerned, when the size is huge and the data set is extremely huge, what happens is that the number of trials and errors that can be performed is huge. So we get the accuracy to be really very much high. When it goes to quality, the quality of the data set should be really good. Relevance is how relevant that particular data it is. If you have a data which is not very much useful for that particular type of information, we have to avoid it. The data set should be very much diverse. The different types of popular data sets are IRIS dataset, MNIST dataset, CIFAR 10 dataset, IMDb movie review dataset, and housing price dataset. Let us see an example for an IRIS dataset. In this IRIS dataset, I am trying to classify the different types of flowers like setosa, versicolor, and virginica based on the value of petal length, petal width, sepal length, and sepal width. These are the sources of data. I have different types of sources of data like .gov datasets, Kaggle datasets, Amazon datasets, Google's dataset search engine, as well as UCI machine learning repository. Most of the time we go for the Kaggle datasets. Data pre-processing was one important step in data set when we use data set for training purpose. We initially give the data set and it performs data cleaning where all the vulnerable details are being removed. Then we go for feature engineering where we train the data and new data is also given inside and we use certain learning algorithms for training that model and score the model and finally evaluate the model where we do the predictions. After this, we get whether the prediction is a success or a failure. Data pre-processing steps involves data cleaning, transformation as well as feature engineering. In data cleaning, we perform different methods of data cleaning are used actually. Ignore the tables, fill the missing value, binning, regression as well as clustering. When we go for transformation, it includes data discovery, data mapping, data extraction, code generation and execution, reviewing as well as sending the data. Feature engineering is actually performed for selecting the data, extracting the data, transforming the data where we get the raw data, and that is actually given for the feature selection, and after that we get the insights whether the prediction is a true or a false. Challenges in working with data set. Accessibility is one important factor where if it is not available or if there are any restrictions, we cannot go for that particular data set. Timeliness, the time of origin of the data set and the availability of the data set is a very important factor. Authorization, in this authorization, whether the rights are already given for that particular data set to be used or not. So after satisfying all these three things, it becomes really difficult to work for this data set. Tips for dataset selection. First of all, we have to understand the problem, what that problem is trying to define. Then we have to define the scope of that problem. Look for the quality. Good quality datasets only should be used. Consider the size. The size of the data should be really high. We have to check for biases and seek diversity. Diverse kind of datasets is very much useful. Data exploration. Here we have different types of data sources and we store the data, and the repository is used to store the data. After that we go for data exploration, and this data exploration and data analysis or mining is actually the same thing, and finally after performing this data exploration we go for the insights and get the app events. Let us see a case study. Here we have iris flower species classification. The problem statement is the goal of this case study is to build a machine learning model that can classify iris flowers into one of the three species, Setosa, versicolor or virginica, based on their sepal length, sepal width, petal length and petal width. This is an example for that. Let us go for the steps in this case study. We have data preparation, data exploration, model selection, model training, model evaluation, model deployment, predictions, conclusion, future work and lessons to be learned from this particular case study. In the data preparation step, we go for exploring the different data sets and prepare the data and explore the data. After that, we have to select the particular model that is to be used and use the training model that is to be used with the specified type of algorithm. Finally, we go for evaluation and deployment and we make predictions whether that particular study is giving me a success or a failure. This is a sample program. First of all, we import the necessary libraries. We import NumPy as NP, import Pandas as PD. These are the necessary libraries that is used for that. And we go for here k-neighbors classification. We have to load the iris dataset, split the data into training and testing tests, and create a k-nearest neighbors. Here the value of k can vary. Here I have given the value of k as 3. Fit the classifier to the training data and make predictions on the test data. Evaluate the classifier's accuracy. Accuracy is very important, and we finally display the classification report for the different types of target names, and also we specify whether the test or the prediction. This is a output of that particular sample program where I am getting an accuracy of 98%. Classification report gives me Setosa, versicolor and virginica, precision, recall, F1 score and support, as well as the accuracy, macro average as well as the weighted average. Based on this, I get the precision or the accuracy to be 98%. Conclusion: in essence, data sets are the raw material from which machine learning models derive their knowledge and predictive power. The ability to find, clean, and work with the right data is a core skill for anyone involved in the field of machine learning. As technology continues to evolve, the availability and importance of high-quality data sets will remain central to the advancement of artificial intelligence and data-driven decision-making. Thank you.